Hey math kids, today we're going to talk about Maclaurin Series. And we're just going to get used to these two formulas through doing an example. So what we're doing here, I'm rewriting f of x like this, and then we just need to find the derivative and notice a pattern. Okay, so I bring this -1 down in front, and since the inside, the derivative is just 1, we kind of luck out with that. It's a plus sign. Okay, so we found these derivatives. Now, to switch the sign, we're going to use, so we're going to write like a general formula for the derivative of f of x, for like the first derivative, second derivative, etc. Keeping in mind that the zero derivative is just f of x. Okay, and to flip this sign, because it's positive, negative, we're just going to do -1 to the k. Because if we do k of 0, that's going to turn into a 1, and we get a positive. K of 1, it's going to be negative. K of 2, because if we square it, it's going to be positive, and then 3 is going to be negative again. So that's just flipping the signs. Now we need to deal with the number out in front, and that's actually going to be a factorial. Factorials show up a lot when we do these Maclaurin series, so always consider that as a possibility. So if we plug in a 0, 0 factorial is equal to 1, and so it's right there. So we're just talking about not the sign, just the actual number. Plug in a 1, 1 factorial, 2 times 1, and then 3 would be 3 times 2 times 1, which is 6. So that one's working out. Then we notice that there's a 2 plus x in all of them. And then this one, we know it's always negative, but then this is step 0, and we have a 1. Step 1 gives us a 2, so it's always just k plus 1. Now we want to look at, if you look at this, all of these we plug in 0. And so we're going to write a formula for that. So this just becomes a 2, because 2 plus 0. And then I'll distribute the negative. And then I can write this 1 a little bit simpler if I write it like that. Okay. Now what we're going to do, we're going to plug it into the formula. So f with the derivative k of 0, so that's what we just developed. So we need to times it by x to the k and put it over k factorial. So we're going to do, actually let's do it this way. So this, if I plug in a 0 for x, we're going to get 1/2. And so then we can just look at it from k equals 1 to infinity instead of from k equals 0 to infinity. And we're going to get this thing, -1 to the k factorial, 2 to the k plus 1. And then the other parts, if we look right here, so I just did this. So we need to multiply it by x to the k and k factorial on the bottom. So k factorial, then x to the k, not the 4, to the k. Alright, if we do that, these k factorials are going to cancel. And so we rewrite that. So we have that, and then we don't really need to keep this separate, so we can say this, or if you didn't even want to pull this out in the beginning, we could just change that one to a 0, we could look at that. Either one's fine. And then we want to find the fourth order Maclaurin approximation and compare it to f of 1. And so if we do that, we just basically use this formula or this formula. So I'll use the top one. But we're going to go from 0 to 4. So we get negative 1 to the k, 2 to the k plus 1, x to the k. And so we already know the first one is 1/2 because we found that right there. Now if we plug in a 1, we're going to get negative 1 to the 1, x to the 1 over 2 to the 1 plus 1, so that'll be 2. Negative 1 squared, x squared, 2 to the 3, and then negative 1 cubed, x cubed, 2 to the 4, and then negative 1 to the 4, x to the 4, over 2 to the 5th. We can simplify that. So we get 1/2. That's just negative 1 over 4x. That's going to be positive 1 over 8 x squared. That's going to be negative 1 over 16 x cubed. And that's going to be positive 1 over 32 x to the 4th. Okay? And so if we plug in a 1 for x, because they're asking us to find m4 of 1, we're going to get 1/2 minus 1/4 plus 1/8 minus 1/16 plus 1/32. And if we do that by getting common denominators, we'll end up with 11/32. And if we compare that to f of 1, so meaning we plug in a 1 right here, we're going to get 1/3. And if we get something close to that, we can times the top and bottom by 11, so that's 11/33. And so we see that those are pretty close to each other. If you need additional help, please come to Math Lab. Until then, calculator.